All right, this is one of the three uh, differential equation methods that we're going to do. Aiden, this is one that we're going to call integrated factor. Okay, it has its own kind of formula set and its method. And the reason it's an integrated factor is if you can put something in the form dy dx plus something times y plus something without a y, we call this p of x, this q of x. You're going to be able to use two formulas to solve this equation. One is I of x equals e to the integral of p of x. And you maybe remember me proving this last year. It was so much fun. And the derivative of y iota, remember that? Equals IQ. And I proved that too. But this is the format, these are the two formulas you're going to use to solve integrated factors that when you can restructure this into this form, picking off p of x and q of x, you can find I and you can solve for the function. So the first thing I'm going to do is I'm going to divide by 1 minus x squared. So this is going to be 1 over 1 minus x squared. Oh, no, that's not right. Let's do it this way. dy dx equals 1 over 1 minus x squared plus x over 1 minus x squared times y. Let's reroute this a little bit. And you're going to get dy dx minus x over 1 minus x squared times y is equal to 1 over 1 minus x squared. This is what? That's p of x with the negative. This is q of x. So with p of x equal to negative, thank you. And by the way, this negative is going to be helpful, 1 minus x squared. And q of x is going to be 1 over 1 minus x squared. This all looks quite horrible, but it's not. Okay, so far so good? So first step, you need to get it in this form, dy dx plus something y equals something without a y. Notice this kind of makes sense. dy dx, y, and 1. Kind of makes sense as far as a structure. And then this is, if you're dividing, so it's dy dx is by itself, your p of x, q of x makes sense as the two functions that could be paired up with a y and a non-y. Now, if we went to the next one, could you see that you might have another function like r of x? Because you could have a d squared y dx squared, a dy dx, and a y, and a, oof, that'll be crazy. So here we go. I of x is equal to e to the integral of negative x over 1 minus x squared dx. Now, why is that negative kind of good? Yeah. What's the derivative of 1 minus x squared? What's the derivative of that? Negative 2x dx. So all I need is this, right? This is going to come to play heavily in the future here because now what you have is e to the 1/2 du over u. And what is that? What is the antiderivative of du over u? Calculus? Natural log of u, 1 minus x squared. Okay, that is e to the natural log of 1 minus x squared to the 1/2, because this property, you could pull that out in front, which is equal to e to the natural log of the square root of 1 minus x squared. Make my day. What's that equal to? Unbelievable. That I of x is just equal to the square root of 1 minus x squared. Done, right? No, we're just getting started. Okay, so next, y iota. So you go the derivative of y times I, which is the square root of 1 minus x squared, is equal to I cubed, square root of 1 minus x squared over 1 minus x squared. Now simplify that for me in your head. What is it? Sure. So this is just going to be d dx y times the square root of 1 minus x squared times 1 over the square root of 1 minus x squared. That's the algebra simplification of that. And when I integrate both sides, you're going to go, you know what? This side, easy. This side, I remember, is something. I remember it. I remember it. 1 over the square root of 1 minus x squared. I remember it. There you go, arc sine of x plus c. Now, no plus c's for the integrated factor I, but there is a plus c for this. Did they ask? No. In part A, we haven't even finished A, have we? So y is just equal to the arc sine of x plus c over the square root of 1 minus x squared. That's your answer to part A. That's the general equation. I'm good with that. Why is the absolute value of x less than 1? Why is that? Why is the absolute value of x less than 1 in their domain? Thank you. Be undefined. Very good. Is it equal to 1? Let's see what the problem said. It's not equal. Yeah. Okay, so everything looks fine. Doesn't have anything to do with it, but it does make that a little clearer. And then it says, for the point 0 pi over 2, can you find the c and prove that apparently c is going to be pi over 2 because we've got everything else. So all we have to do is find c. So when I plug in the pi over 2 for y and the 0 in for x, I get pi over 2 is equal to 0 plus c square root of 1. That's okay. It's saying here, when f of 0 is pi over 2, this equation should be the case. So in other words, x is 0 and y is pi over 2 will get me, and yep, that's right. It is, I showed that c is pi over 2, so that's going to be my equation. Just to play with your brain a little bit, and I love this question, then it says take the limit as x approaches, is that -1? Of f of x. So take the limit as x approaches -1 of arc sine of x plus pi over 2 all over the square root of 1 minus x squared. These test writers are very clever because what they're trying to assess here is that you know whose rule? L'Hopital's, yeah. And what's the first step to L'Hopital's? What do you have to do? Yeah, you're going to put in a -1. So arc sine of -1, which might freak you out a little bit, over the square root of 1 minus -1 squared. Well, the bottom is 0. But what is the arc sine of -1? What is that? That is negative pi over 2. And what's negative pi over 2 plus pi over 2? That's an indeterminate form. Remember that? Now take the derivative of the top, derivative of the bottom, limit as x approaches -1, the derivative of the top, arc sine is 1 over the square root of 1 minus x squared, derivative of pi over 2 is 0. The derivative of, boy, it's been a while, 1/2, or 1 minus x squared to the 1/2 will be 1/2 1 minus x squared to the -1/2 times -2x. Y equal to 1 minus x squared to the 1/2. 1/2 this to the -1/2 times the derivative of the inside, -2x. So this is going to be equal to the limit, x approaches -1, 1 over the square root of 1 minus x squared over, can I cancel these 2's? Will you let me do it? Oh, that thing is tracked. Just a second. So this is going to be negative 1 over the square root of 1 minus x squared. What happens next? Those cancel out and you get -1. And go ahead and look at that answer. I think it is -1. So I jumped that too quickly here. I got this negative here, but what's x? X is -1. So what's -1 times -1? I think it should be a +1. So good catch, guys.